Yeah, the next three-dimensional coordinate system is the extension of circular coordinate system along Z, and is called as now cylindrical coordinate system. Yeah, in the case of Cartesian coordinate system, we saw this. Taking this as x coordinate, x-axis, taking this as y-axis, we extended them in z direction and created one more axis called as z-axis. Thereby creating three mutually perpendicular planes, xy, yz, and zx planes. And every point is then represented as the point of intersection of three planes. And these three planes are the planes parallel to these reference planes. X is equal to constant plane parallel to yz plane, y is equal to constant plane parallel to xz plane, and z is equal to constant plane parallel to xy plane. This is how we got surfaces, right? One surface like this, one surface which is like this, and another surface is xy surface, it's plane itself. In the same way, now listen, now we created z-axis and then defined z is equal to constant surface which is parallel to xy plane, intersecting z-axis at the constant z is equal to z naught. Now, the cylindrical coordinate system is same. Basically, we had xy plane in which we had a circle, correct? In xy plane. One line was circle, another line was the radial line, correct? We were talking about this as the point of intersection of the circle and the radial line, because of which we could give the coordinates of that point in xy plane as well as circular plane. Now creating again z-axis, which is perpendicular to this particular plane, z positive upwards, negative downwards, like no x positive towards us, negative away from us, y positive to the right and negative to the left. If I extend this circle, locus of the circle moved in the vertical direction will give me a cylinder. Will give me a cylinder. So circle becomes cylinder. And if we extend this radial line in z direction, please see this. It will become a plane surface, right? Earlier, the radial line was making an angle phi with x-axis. Now this plane is the plane that is making an angle phi with xz plane. Listen carefully. Earlier, rho is equal to constant rho naught, phi is equal to phi naught constant was a point. That rho is equal to rho naught constant when it is extended along z-axis. It became a cylinder of radius rho naught having z-axis as its axis. This is the cylinder of radius rho naught. Rho, actually rho naught having z-axis as its axis. This is the plane. Starting from z-axis, it should not go backward. That's what I was talking about. It's a radial line. Here it is, plane starting from z-axis. And making an angle phi with xz plane. Correct, no? Please see, this is what we did. Now I'll change its color. This is the first thing in the order. Circle in the circular coordinate system extended along z-axis from z is equal to minus infinity to plus infinity. Whenever I have to give the coordinates of a point in space in cylindrical coordinate system, given a point, I will draw a cylinder of radius rho equal to distance of that point from z-axis with z-axis as its axis, first coordinate. Then I will consider a plane starting at z-axis and making an angle phi with xz plane. This is the plane. That is making an angle phi with xz plane. Intersecting the cylinder along this vertical line. Hope you are able to perceive this, right? It comes out of the cylinder. Earlier also in Cartesian coordinate system, when you give the first coordinate x is equal to x naught, from infinite three-dimensional space, given one coordinate, it came onto the plane, which is an infinite two-dimensional surface. If you give one coordinate, only two variables are uncertain. That means it comes onto a plane. If you say that this point is there in one more plane, since the point simultaneously lies in two planes, the locus of any point which lies simultaneously on two different planes is the line of intersection of those two planes. When no coordinate is given, all the three variables are uncertain. One coordinate brings it onto plane, only two variables will become uncertain. If you go to the next coordinate, it will be a line, only one variable is not known. Two variables are fixed. And that line is cut by z is equal to constant plane. To the specific point. X is equal to x naught, y is equal to y naught, and z is equal to z naught. Now, having given these two planes, phi is equal to phi naught, because the other axis is z now. X and y just as the reference lines for us. How to go to the point? Plane parallel to xy plane and intersecting z axis at z equal to z naught. This line, whatever is produced, this vertical line, and z is equal to z naught definitely is a horizontal plane which cuts the line at this particular point, because of which the point will get the coordinates rho naught, phi naught, and z naught. Check it, please. Is it clear? Here, what we did is every point is represented as the point of intersection of three surfaces. Number one, cylindrical surface of radius, in general rho, having z-axis as its axis, infinite cylindrical surface in length. So first coordinate. Given a point, we will first draw a cylinder through that particular point in such a way that that cylinder has z-axis as its axis. Then number two, vertical plane extending from z-axis making an angle of angle phi with xz plane. Once you give this, it will come onto a vertical line. Next, 3, horizontal plane perpendicular to the axis, parallel to xy plane reference, parallel to xy plane, intersecting z-axis at z, because of which the coordinates of the point are rho, phi, z. Please check it once. You should be in a position to visualize it. That's important ultimately. wherever the field has, I will show later when the point 10 comes. Wherever the field of a source has cylindrical symmetry, we should select cylindrical coordinate system to derive the expressions for that particular field. Wherever the field has cylindrical symmetry, we should select cylindrical coordinate system to describe that particular field. The first one, given rho naught, phi naught, z naught, the coordinates of the same point in Cartesian coordinate system is what? Definitely rho naught cos phi naught is equal to x naught, rho naught sin phi naught is equal to y naught. I think you agree that. Because rho and phi did not change, I just created the extension in z. The same point which was there on the circle of radius r, on the radial line making an angle phi. Right? Now it came up. When it comes up, its z coordinate only should change. Because of which only the device we represented this as what? Circle is represented as a cylinder, and that radial line was represented as a plane, so that the coordinates won't change when it moves up. Rho and phi are the same, and z naught is equal to z naught. This z naught is same in all the coordinate system, both the coordinate systems. And given x naught, y naught, z naught, rho and phi are determined by x naught and y naught only. Rho naught is root of x naught square plus y naught square only. And then phi naught is equal to 2 pi plus tan inverse of y naught by x naught if x naught is greater than 0. Pi plus tan inverse of y naught by x naught if x naught is less than 0. Z naught is equal to z naught. Wherever we require conversions. Please check. Next. Just tell me, there are 3 surfaces. In Cartesian coordinate system, given one coordinate, it comes onto one plane. Second coordinate comes onto 2 planes, because of which comes onto the line of intersection, straight line of intersection. Any 2 coordinates if you give, it comes onto a line parallel to either x-axis beyond which x coordinate is to be given, y-axis beyond which y coordinate is to be given, z-axis beyond which z coordinate is to be given. Final coordinate, then you go third coordinate, it goes to the point, required point. Here, listen carefully. If you give rho or phi or z, it comes onto the surface, and surfaces are defined. If you say that the point lies on As the coordinate rho is equal to rho naught and phi is equal to phi naught, it comes onto a line parallel to z-axis. Do you appreciate this? Because that point extended in that direction is a line parallel to z-axis. If I give rho is equal to rho naught and z is equal to z naught, what is this line? It is the cylinder of radius rho naught cut by a horizontal plane at z is equal to z naught. What did I get? Huh?
A circular disc.
Circle, that's all. Right? It's a line. Disk is a surface. No, it is not surface here, right? Rho is equal to rho naught is a surface. Hollow cylindrical surface, correct? Z is equal to, it's a circle of radius rho naught on z is equal to z naught plane. Next, phi is equal to phi naught and z is equal to z naught. I think I've taken all the possible combinations. Rho phi z, phi z. If phi is equal to phi naught and z is equal to z naught is given, it is a try to visualize. Phi is equal to phi naught cut by z is equal to z naught. It is a radial line extending from z axis. Making an angle phi with xz plane on z is equal to z naught plane. Phi naught with xz plane on z is equal to z naught plane. So given two coordinates, it comes on to one of the lines, right? It can be a straight line, infinite vertical line going from minus infinity to plus infinity in z, or a circle of radius rho naught and z is equal to z naught plane, or that radial line. Same as the radial line that we had in circular coordinate system, but above the xy plane, the same line is now lifted up and then rotated. Check it. Now the vectors in cylindrical coordinate system. As usual, vectors in cylindrical coordinate system are of the form rho component A rho plus this fellow is useless. Is it? It's not received. I was there for some time. How come? Hey, Basvesh, initially you were there in the class, no? Or just now you tried to attend?
I did it just now, sir.
Huh?
I got the link now, sir.
Hey, you should have called me then itself. 4 o'clock, when you say 4 is the time, immediately you should call, because I will send everybody, but some people won't get.
Okay, sir.
Yeah. They are of the form aero, the radial component only. And then phi component, tangential component to this. This is definitely radial to the cylinder. That's what we are going to see. This is tangential to the cylinder. Earlier it was radial and tangential to the circle. Because it is just extended, they become radial and tangential to the cylinder. Plus normal AZ, small AZ component. This is radial. This is tangential to the cylinder. This is vertical. The first two are horizontal components. And the last one is vertical component. Now we should now define A rho, A phi, and AZ. Check it now. I can go to the top figure, but let us not have a confusion over it. This is the first coordinate, radial. Because of which it comes onto the cylinder. This is naturally z-axis. It is cut by a plane. Making an angle phi with xz plane. Because of which you will get a line of intersection of this cylinder and the plane. Now let me put it in both, right? This This is the line of intersection of the green cylinder and red plane. And the third coordinate is z is equal to z naught plane, because of which it is this. Vertical line is cut by this z is equal to z naught plane, where this meets z at z naught. Now we need to define arrow. I think we are experts in this now. What is arrow? At any point in the space, this is the point of interest we are talking about. At any point in the space, arrow is the vector of unit magnitude perpendicular to rho is equal to constant surface passing through the point. It's a cylinder in the direction of increasing rho. In the direction of increasing rho means, what is this actually? Normal to the cylinder is radial line. This is arrow. Same as arrow there. Here also we can imagine a circle. That is the radial line to the circle. Then this is the radial line to the cylinder. Vector of unit magnitude at any point. Perpendicular to arrow. What is this? Rho is equal to constant surface passing through the point in the direction of increasing rho is arrow. Next, AFI is what? Vector of at any point, at any point, vector unit magnitude perpendicular to phi is equal to constant surface. Is this red surface actually passing through the point in the direction of increasing phi? What is that? On z is equal to z naught plane, it will be there. Arrow as well as AFI. AFI is tangential to the cylinder. AFI. Perpendicular to arrow component. One is radial to the cylinder, another is tangential to the. These two are horizontal unit vectors. Is it? Z is equal to constant surface passing through the point in the direction of increasing Z. This is AZ. Check it. AZ always has a unique direction, vertically upwards. Wherever you go, AZ, because it is same as the AZ in Cartesian coordinate system, it will have unique direction, but arrow and FI have different directions depending upon where we are defining that. In fact, where means which phi, right? the directions of arrow and A5 are not unique. They are mutually perpendicular. But the direction of AZ is unique. Always maybe vertical. That's what is the rotation. I don't know how much comfortable you are. I'm ready for the discussion. Since arrow and A5 have no unique directions, it is not possible to define a vector from any point to any other point. This is what you are telling in the circular coordinate system. But there we gave a statement. On any phi plane, on any phi lane, phi is equal to constant line. If I have 2 points, I can represent the vector from one point to the other using the radial component. Because it is a straight line. Whenever, listen carefully now, I talk about a vector from one point to the other point, I should have produced each component. If I'm producing rho component without changing phi and z, I should change only rho and produce the component. It is not possible for me to change only phi along a straight line because it is a straight line component that we talk about. Component cannot be curved line. It is not possible for us to produce phi component by changing only phi, keeping rho and z constant. This we saw in circular coordinate system itself. So it is not possible for me to produce a phi component without changing the other two coordinates. But it is possible for us to produce a z component without changing rho and phi. That's what, it's a vertical line on which z and phi coordinates are always constant. We told it in the beginning itself. Rho is equal to rho naught, phi is equal to phi naught itself is a line parallel to z axis. You can vary z without changing rho and phi. Listen. If 2 points are there on same phi plane, correct? For example, rho naught, phi naught, rho naught, phi, z naught, and rho 1, phi, z1. As soon as I see this point, because phi coordinate is same, they are on same phi plane. Now we can define a vector. If I want to go from rho naught phi z naught to rho 1 phi z1, what is the vector from this point to this point? I will travel only from rho naught to rho 1 at z naught. At height z naught, on the right plane phi is equal to phi on phi plane, I will produce rho 1 minus rho naught a rho plus now mutually perpendicular direction now. On z is equal to z naught plane, I moved from on definitely yes on the line of intersection of z is equal to z naught plane and phi is equal to phi plane. I varied only rho. Now I had to vary z from z naught to z1. Definitely, when I vary that along z axis vertically, rho and phi components will remain constant, because of which it will be z1 minus z naught az. A general vector is only this much. If phi is different, it is not possible for me to define a vector. Given any 2 points, we can define a vector in Cartesian coordinates. We know that.